Hi, my name is Philip Ken. Today I'm going to present Hadoop Sqoop, a mechanism for transferring data to and from HDFS. So the agenda will be, what is Sqoop? Why Sqoop? The pros and cons of Sqoop open source project, and we'll break into 4 demo exercises. So let's start with why Sqoop. There was a need to move certain part of data from traditional SQL database to Hadoop. On the other hand, since traditional databases already have reporting, data visualization, and enterprise applications built in enterprise as of today, why not bring in processed data from Hadoop to those applications? Sqoop 1 architecture. Sqoop 1, this is a client install only, with a client-side interface. Now let's notice in the Hadoop, there's only map task, there's no reduce tasks. How Sqoop import works. 2 steps. Step 1, get the metadata for the data being imported. Step 2, using a map-only Hadoop job to carry out the import. Similarly, in Sqoop export works, also 2 steps. Step 1, same as import. Gather the metadata about the database for export. Step 2, Sqoop will first divide the import dataset into splits, followed by Sqoop using individual map tasks to carry out the splits to databases. Sqoop 1 demo. We are using 4 separate exercises. First exercise, test the connection to MySQL database. Import MySQL table into HDFS, and then controlling the import. And that means in the command line of the import, I can insert the business conditions, such as a where statements equivalent in SQL, as well as what's the columns I want to import, if I do not want a full table import. And last but not least, export table from HDFS back to MySQL database. And this is the snapshot of import MySQL table into HDFS. And as the result shows, that this import job will generating 5 HDFS files. And this is the snapshot for controlling the import. And let's notice here, we have additional argument where ID less or equal to 100,000. And also use the columns argument. I only want to import 3 columns rather than the full table import. And the last one, the snapshot, will show how the export job looks like. And let's notice here the argument -m1. That means I only want to using 1 map tasks. Now next, we're going to run a 2 lab demo. The first one will be the import. The second one will be the export. Now in this demo, we're going to run a import. Import a selected columns. In this case will be the first 3 columns of the same table, but this time with conditions where the ID is less or equal to 100,000. And that's approximately half the size of the original table. Okay, it's done. It's retrieved 486 records. Now we're going to take a look in the results in the HDFS file system. Okay, in the HDFS, it generates 3 separate files. And let's take a look at the first one. And what we expect to see, it should show us the first 3 columns, which is correct. Now next, we're going to run the export job. And this is the export command line looks like. So what this does, it exports the same HDFS file back into the MySQL table. Okay, exported 486 records. So let's match. So now let's take a look at the results in the MySQL tables. It shows only 3 columns and the total row count 486. Sqoop 1's challenges. Its command line only arguments lead to error-prone connect matching. Its tight coupling between data transfer and serialization format means different connectors supporting different data formats. It has security concerns. It does not have role-based security credential. Not easy to manage, configure, install. Not easy to monitor map jobs. Connectors are forced to follow JDBC model. And Sqoop 2 is a work in progress to address those Sqoop 1's drawbacks. Now let's take a look at Sqoop 2 architecture. Sqoop 2 adding a web-based GUI that exposes a simple user interface. Using this interface, a user can walk through an import-export setup by UI queues that eliminate redundant options. The UI is built on top of a REST API that can be used by a command line client, exposing similar functionality. Whereas Sqoop 1 requires client-side installation and configuration, Sqoop 2 will be installed and configured server-side. This means that connectors will be configured in one place, managed by admin role and run by the operator role. Sqoop 2 will be a web-based service, front-ended by a command line interface and a browser, and back-ended by a metadata repository. Moreover, Sqoop 2's service-level integration with Hive and HBase will be on the server side. RZ will manage Sqoop tasks through the REST API. In Sqoop 2, connectors will no longer be restricted to the JDBC model, but can rather define their own vocabulary. So what's next? Since Sqoop is an open source project, and here is some examples current developers are working on. For example, HBase integration. Import from a database to a table in HBase. Free form query support. Sqoop's existing import model is table-driven. You can now import data from an arbitrary select statements against your database. Update support. Export a set of updated statements against an existing database rather than a set of new records. And here is some links for the Sqoop resources, including the project website, wiki pages, project status, and the mailing lists. And now I'm ending my presentation. Thank you.